Hello everyone, me Fatma Najar and on behalf of Nizar Bouguila, hope all is well for you. Today we are representing our work entitled Happiness Analysis with Feature Information of Dirichlet-multinomial mixture models accepted in the Canadian AI Conference. Today I will represent the motivation, what is the problem that give the opportunity to propose this approach, what are the experiments that are done to validate the proposed model, and then we conclude this presentation with a conclusion. Happiness actually is the best feeling that we wanted to feel it and to live it in this life. Could we measure happiness using AI? Actually, yes. We could do this using emotion recognition that is based on two important clues. The first one is a robust feature representation, which is usually based on action units and VAD emotional state, and also a discriminative classification method. In this regard, we are proposing a new feature representation that is based on VAD emotional state. Our approach based actually on a good well-known model for count data, which is the Dirichlet-multinomial distribution. This distribution is based on the combination of multinomial distribution and Dirichlet distribution. And an important clue in this statistical model and in every statistical model is the feature information matrix, which measures the amount of information of a local parameter. However, this feature information is usually approximated and replaced by the identity matrix or some approximation. But Polyol have proposed the exact feature information for Dirichlet-multinomial, which motivates us to propose a new feature scoring based on the exact feature information to estimate the parameters of the mixture of Dirichlet-multinomial. And from this algorithm, we propose the exact feature vectors for the image representation. So our proposed model is based on the mixture of many Dirichlet-multinomial distribution. So the algorithm is based on the expectation maximization estimation method, which is actually start by using the k-means algorithm and the method of moment. And then repeatedly we estimate the parameter. First we estimate the posterior distribution and then we estimate in the M step the parameter using the Fisher scoring algorithm until the convergence of likelihood. Using the optimized parameters, we calculate the exact Fisher vector. So using the exact Fisher matrix and the exact and the score function, which is actually the gradient of likelihood, where we estimate, where we calculate the derivative of the likelihood. And here actually the models is to take all the image and to extract the feature from each image. The feature here are supposed to be the SIFT or the LPB, and then we represent those features by the mixture of Dirichlet-multinomial, and we estimate using the Fisher scoring to get the exact Fisher vector, and then we fit those vectors to the SVM. So to validate our model, we used the EMOTIC dataset, which is a new dataset proposed in 2019. So this dataset includes 23 million images and a huge number of people, 26 discrete categories, and based on the VAD emotional state model. Actually, to analyze the happiness, we extract a subset from this dataset, which include just 6 emotional intensity, which are affection, excitement, happiness, peace, pleasure, and sympathy, which some example of those feelings are represented here in this image. So to compare our proposed feature vector, we also applied the Bagel feature representation and also the approximated vectors to compare the effectiveness of our representation. Also for the learning method, we compared the Fisher scoring with the expectation maximization, which include in the M-step in Newton-Raphson method. Also, we extracted the feature using SIFT vectors and also MBLPP. So the results prove here that our models outperform all the other models. So we can see that the Dirichlet-multinomial combined with the Fisher scoring, the SIFT, and the exact Fisher vectors achieve the best results, and we can see that the approximated Fisher vector using the exact information matrix from the Fisher scoring have also comparable results. But if we see here that the Dirichlet-multinomial combined with the EM and the SIFT, but represented using the Bagel feature for the image, the accuracy is really very low, where we can see that we cannot detect the happiness using this representation. So to analyze the happiness intensity, we tested also using all the methods, and we find that our proposed model, the Dirichlet combined with the Fisher scoring and also the exact Fisher vector, outperforms all the other methods and also the CNN, which is in the literature review. We can see also that the most intenseful feeling is the happiness and also the pleasure. So we can say that the Fisher vectors play an important role than the approximated Fisher vector, the bag of feature, and also the CNN. It's important to mention also that the Fisher scoring method and the Fisher vectors, which are based on the exact calculation of the Fisher information matrix, take into account the dependence between features, as they didn't assume that the off-diagonal elements are 0. So we conclude this presentation by saying that we have successfully proposed an efficient model to represent images using Fisher vector. We introduced a new mixture models inference using Fisher scoring algorithm to estimate the mixture parameters of Dirichlet-multinomial. We compared the exact and the approximate calculation of Fisher vectors, and we prove that the exact provide the high efficiency. So thank you very much for your attention, and I will be it's my pleasure to have your question using my email.